now that the theory is out of the way, let's look at the examples. And I think Valentina did one last time, so I will do different ones. Okay, example 1. Find the area between y equals x squared and y equals 2x minus x squared. Is this board in the way? Well, I'll move it anyway. No one needs to exit. Okay, so what's the step? Well, I should kind of know what that area looks like, right? So what do you recommend I do? Graph it, right? When in doubt, always look at a picture. So I will attempt to graph these two functions. Y equals x squared, always easy to graph, right? Always a pleasure. This is y equals x squared. Okay, halfway there. Now, to graph 2x minus x squared, there are a couple of ways I can do this. The most basic, straightforward way is to just plug in x values, which I could do. One thing I'm going to prefer to do, though, is I'm going to actually solve and see when this is equal to 0. Because if I can find out when it's equal to 0, I know this is also a parabola, right? It's x squared plus 2x, and it's also an upside down parabola because of the negative in front. So I can use that to guide me without actually plugging in values all day. So I'm going to go ahead and factor this. I can factor out negative x, and that will leave me with x minus 2, which if I set equal to 0, tells me that either x is what or x is what?
0.
X is 0 or x is 2, right? So here's x equals 0. Let's go ahead and say that that's x equals 2. So it has those two roots, which means that it must peak right in the middle, right at 1. So what I'd like to figure out is what happens if x equals 1. What will y be equal to?
1.
Yeah. It'll be 2 times 1 minus 1 squared, which is 1, right? So when x is 1, y is 1, which we should know is right on the curve for x squared, right? 1, 1 is a point there. So my parabola should look something to the effect of that. Right? So that's 2x minus x squared. So the area between the two, we now see is this green area right here. Right? Okay. So far, so good? Of course, if this feels confusing, you'd always just plot points and then get the exact graph, but we like to take shortcuts. So now I'd like to find this area. How do I do so? Set up an integral, right? So the area between y equals x squared and y equals 2x minus x squared should be an integral. What integral would you set up?
You know that the two endpoints for the area would be 0 and 1. So
Yeah.
0 to 1.
X goes from 0 to 1. That's where my area starts and ends.
And then the negative x squared plus 2x is above the x squared, so it's bigger times smaller.
Exactly. Once I have a picture, it's pretty obvious that the red curve is above the blue curve in this case. So it's the bigger function on that interval. So I take 2x minus x squared minus x squared dx. Right? Now, one thing that you should never ever do, because A, it's wrong and you'll get wrong answers, and B, you will lose credit, is to assume which function is the bigger and which one is the smaller, right? For example, it's a very natural thing, and I've seen this before, where people say, well, x squared has a positive coefficient, but negative x squared has a negative one, so x squared must be the bigger function. That is nonsense in every way, shape, and form, and that's not acceptable, right? Some way you have to figure out what the bigger function is, either by drawing the picture or by actually calculating which function is bigger on that interval. For example, you could take the number 1/2 and plug it into each curve and see which one gives you the bigger value, right? But some way you have to figure out mathematically which is bigger. So we get this integral, and this is not a hard integral, so let's just do it. If I simplify what's inside, that's 2x minus 2x squared. And now if I find the antiderivative, what would I get?
X squared minus 2/3 x cubed.
Very good. X squared minus 2/3 x cubed from 0 to 1. So first I plug in 1, and I get 1 squared minus 2/3 1 cubed minus whatever when I plug in 0, which is 0. It's just a bunch of zeros and a bunch of x's, right? So everything goes to 0. And if I simplify this, I get 1 minus 2/3, which is 1/3. So that's what this green area is. It's exactly 1/3. Right? Questions? Concerns? Make sense? Okay. Let's move on then.